Hello, and welcome to our presentation. Our team is We Are Your Asset, and we're excited to be presenting to you today on the work we carried out on Challenge 5, Visualizing Risk Geographically. As part of this presentation, we're going to talk you through the team members, the problem statement we were set, the methodology we decided to adopt, the steps that we went through to complete the task, and finally we will answer the questions that were set to us. So as part of our team, we had Daniel Murphy, who put a lot of effort into the modeling and dashboard, myself, James Steele, who worked on the Borough Mesh, and Stefan Marsnick, who put a lot of time into the automated report.
The problem statement, as described on the challenge document, is as follows. I want to compare my environmental risk assessment to asset locations. I want to see on a map what assets are most at risk and filter my data to show different things. I want to be able to create new risk assessments automatically from this data and use it to inform on where to prioritise funding to protect assets. As a team, we broke the challenge down into the following 4 steps. The creation of a borough mesh to increase asset classification. A model for risk. A dashboard to display our results, and finally, an automated report to send weekly emails of the highest risk assets.
So the first step we wanted to undertake was the borough mesh. We wanted to provide more information on where the asset was located. So to do this, we needed to create a mesh which consisted of multiple sections within a borough, and then each one of these sections had coordinates. So what we did is we created a SQL data flow, and then using the SQL function, which you can see in front of you, we were able to identify which asset was inside which borough. And then the output you can see on the bottom right, and then the mesh you can see on the bottom left.
A risk model was created based on how susceptible the asset is to flooding. There are 4 different tiers to the model, and the logic used in assigning these tiers to each asset is described on the slide. Following the precedent in the dummy surface asset climate risk data file, the risk tier is increased by 1 in the year 2050, and the tier is kept at this level in 2080. A dashboard was created within Power BI. This allowed the assets to be displayed on a map and filtered based on their borough, risk category, asset type, asset owner, and asset ID. The assets were able to be plotted using their latitude and longitude, which is contained within the dataset. Asset ID is searchable. This allows the user to follow up on insight gained from the automatic reports described later and drill down into the detail contained in the asset.
As part of our brief, we were asked to generate an automated report to send out to key stakeholders. We decided to use Power Automate for this feature. As you can see on the screen, a recurrence is set on a weekly basis, which generates a list of items from the report. You're able to look at asset IDs, owners, location of these assets, and it also gives you a flood risk rating for 2020, 2050, and 2080. So you're able to identify which asset has the greatest problem at which point. An email is then sent to the relevant stakeholder who's able to interpret the data. On the screen, you can see the report that is generated from the Power Automate flow. On this report, you're able to identify each individual asset on the TfL network, which is assigned to location, whether it's located within a flood zone, what the flood risk rating is for 2020, 2050, and 2080, as well as being assigned to a risk code for each of those years. The flood risk rating is assigned between minor, moderate, major, and severe, which allows the stakeholder to identify which asset needs immediate attention. The first question that was asked of our team was to identify whether there were any gaps in the data. Generally in the data, it was clean. However, there were a number of gaps in the specific columns, such as chamber construction type for our gullies, light height for our lamps, and tree species for our trees. We recommend an extensive assessment of the assets to be undertaken to ensure the data is more comprehensive. Our second question was, what other data would you have collected and how would this improve your data model? This would be improved by having a mesh or coordinates of the River Thames to identify the relationship between distance from the River Thames and flood risk. We would have taken climate data to create a more accurate and detailed model year by year of increased flood risk. We would love the opportunity to link this data with information about surveys so we could calculate the deterioration of assets over time and how flooding might accelerate this process.
The third question we were asked is, what would you have done with more time? So, I mean, there are so many answers to this, but we could try to kind of pinpoint the main three. So the first one was we would have liked to create a drill down or a tool down tip on the map to provide more data on the asset. Through the borough mesh, we realized that there was an 83% accuracy, which given the time we had was quite good, but 17% of points were not picked up, and some of them on the edges of boroughs were kind of in the wrong borough. So we'd like to create a more detailed mesh, probably with about 100 sections, just to make it more accurate. And finally, we'd like to discuss requirements for TfL to provide a more detailed Power Automated report, highlighting key metrics. Question 4. How would you apply these principles to other types of risks and other types of assets? So I mean, essentially the tool, once it's set up, all you have to do is change the asset type. So we could have buildings, tube lines, bridges, and London City Airport information. I hope you enjoyed our presentation. We believe we did the best we could with the time we had. We took on something new. Each one of us has learned new skills, so thank you very much for the opportunity. This is Team We Are Your Asset.